Alright, college trig here, 7.1, the start of chapter 7. We're looking at right triangle trig, a lot of stuff from geometry class and application type problems. So, what's the difference between these two? So we should notice that for the first one, our unknown is in our denominator. So when we cross multiply, if we have this over 1, we're going to get x times the tangent of 42 equals 6. Solve for x, we get x equals 6 over tangent of 42. Notice for this one, we have x in the numerator. So if we cross multiply, we get x equals 6 times the tangent of 42, which will give us a different answer than the previous one. So notice this one, the third one, our unknown is here as our angle, or our theta. So in order to undo this, we have to use our inverse tangent, both sides. So we find that theta is equal to tangent of -1, 7 over 10, and we can get our solution there by putting it into our calculator. So we'll be dealing with a lot of this right triangle trig here in 7.1. Just wanted to highlight the differences here when we're solving. So solving for an angle for the blue, solving for a angle in the numerator of our ratio in the green, and solving for the denominator in our ratio in the red. So use the figure alpha equals 4 and or a equals 4 and alpha equals 35 degrees to find b, c, and beta. So I strongly encourage you guys to use the angle that you're given in case you make a miscalculation to find beta. Then if you use beta's angle, then the whole problem will kind of fall apart if you just did a simple calculation wrong. So I encourage you to use the things that are given to find as much possible information from there. So let's go ahead and look at, we can just decide if we want to solve for b in reference to 35. Well, I know 4, so this is my opposite and adjacent. So then I'm going to decide which trig function deals with opposite and adjacent. Well, that's tangent. So I have tangent of 35 degrees is equal to 4 over beta. And like we looked on the other side and solve this out, we'll get beta is equal to 4 over the tangent of 35. So I can go ahead and get my calculator out and solve for b by doing 4 divided by the tangent of 35. Because I'm touching tangent, I want to make sure I'm in the right mode in degrees, and I'm going to see that I'll get a side length of 5.71. Okay, so then from there, we have found beta. We can go ahead and find c. We're always going to have options here with different ways to find them, but again, I don't really want to use b in case I did that calculation wrong. I want to use what I'm given. So here, I'm going to use, again, it's still opposite. Now I have hypotenuse. Well, what deals with opposite and hypotenuse? Well, I'm going to deal with sine of 35 is equal to 4 over c. Again, cross multiply, see that c is equal to 4 over sine 35. And that's going to be approximately equal to, with my calculator, 4 divided by sine of 35. And we'll get our answer there, which seems right. Our hypotenuse should be our longest side. So we get 6.97. So from there, I got my b and c. My last thing I need to do is go ahead and find my beta there. I think the easiest is just using our triangle sum theorem, that all three angles add up to 180. So I got beta plus 35. We know that a right angle is 90 plus 90 is equal to 180. Click terms, and I get 1 plus 125 is equal to 180. So I'll get beta is equal to 55 degrees. Noticing that these are both complements. Okay, so we went ahead and solved for A, B, and C on that one. So, angle of elevation, angle of depression. Always remember that your one side of your triangle has to be your horizon. Okay, so your angle of elevation is always coming from your horizon to your line of sight. So that is your angle of elevation if you're referring to it in that way. Your angle of depression, again, you still have to deal with your horizon line. And it's the angle from your horizon line to what you're looking at. The most common mistake I see here is students trying to draw a triangle here and calling this your angle of depression. There's no horizon line here as a side of your triangle. Always have to have a horizon line in these angle of depression and angle of elevation type word problems. So we talked about that in geometry. Okay, so make sure, just as a refresher here. So last slide here, we're going to do a practice problem. So for this word problem, notice I went ahead and drew a picture here so you can see when we talk about this transit, it's just a device used to find angle of elevation and depression. So that's just 2 feet off the ground there. So we'll have to consider that at the end of our problem. So when we look at this, we want to figure out the height of the tree. So our first thing is we got to understand the height of the tree is going to be the height of this right triangle. This is going to be congruent to that here, where this is my right triangle, and then here this is 2 feet. So I'm going to find the initial height of the tree, and then the next year's measurement with a new angle of elevation of 11.9 degrees, and see if it actually did grow 12 feet. So in order to find this, I'm going to call this H1. So to find H1, I notice that that's opposite, and I know my adjacent side. So that's tangent of 5.7 is equal to opposite H1 over my adjacent side, which is 100 feet. So I solve this out, and I get H1 is equal to 100 times the tangent of 5.7, which is going to be approximately equal to 100 times tangent of 5.7, making sure our calculator's in the right mode, and we get 9.98 feet tall. Alright, so next, to see if we actually grew it, now I have to find this height, which is H2. So H2 is going to be the tangent of 11.9 degrees is equal to H2 over 100 feet being my adjacent side, and I'll multiply this through, and I get H2 is equal to 100 times the tangent of 11.9, which is going to be approximately equal to and we get approximately 21.0 feet. So to find the conclusion, is the nursery's claim true? Did it grow 12 feet per year? Well, we don't really care about this 2 feet, so that's just kind of a distraction in there because we're just worried about this growth. Is this equal to 12? Well, that's just going to be H2 minus H1, which is equal to 21.07 minus 9.98. So second answer minus 9.98, and I see that we get 11.09 feet of growth. Feet of growth, so the nursery lies. So we'll do some more application problems tomorrow in class. Thanks for taking notes tonight.